Acid-sour water corrosion in oil and gas processing, challenges of corrosive fluids affecting industry equipment. Overview and introduction to acid-sour water corrosion. Acid-sour water corrosion is a critical issue in oil and gas processing environments where water contains dissolved hydrogen sulfide, H2S, and exhibits a low pH, typically between 4.5 and 7.0. This acidic condition significantly increases the corrosivity of the environment, especially toward carbon steel equipment. Acid-sour water often forms in overhead systems of distillation units and other areas where condensation occurs, creating localized zones of aggressive corrosion. The presence of H2S not only lowers the pH but also introduces sulfide ions that contribute to sulfide stress cracking, SSC, and hydrogen-induced damage. These conditions demand stringent material selection and operational controls to prevent catastrophic failures. Understanding the nature of acid-sour water and its implications is essential for maintaining equipment integrity and ensuring safe operations in refineries and petrochemical plants. Key characteristics and implications, factors influencing corrosivity. Several factors make acid-sour water highly corrosive. First, the low pH environment, often below 7, accelerates metal dissolution and weakens protective oxide layers on steel surfaces. Second, low ammonia, NH3, levels exacerbate the problem because ammonia typically neutralizes acidity. Without it, the water remains aggressively acidic. Third, low chloride concentrations, less than 50 ppm, combined with H2S and low pH create a unique corrosion scenario where sulfide stress cracking becomes a major concern. These conditions are governed by industry standards such as NACE MR 0175 or ISO 15156, which specify material requirements for sour service environments. Failure to adhere to these guidelines can result in severe metal loss, cracking, and equipment failure, posing significant safety hazards and operational risks. Why acid-sour water is a problem, corrosion and safety risks. The combination of H2S, low pH, and insufficient neutralizing agents creates an environment that accelerates corrosion and leads to structural degradation of equipment. Carbon steel, commonly used in refinery systems, is particularly vulnerable, experiencing general thinning and localized cracking. Sulfide stress cracking, SSC, occurs when high-strength steels under tensile stress interact with wet H2S environments, even at low concentrations. This can lead to sudden and catastrophic failures. Additionally, the presence of H2S introduces severe safety hazards due to its toxicity and flammability. Equipment failure can result in leaks, exposing personnel to harmful gases and increasing the risk of explosions. Operationally, these failures cause costly downtime, repairs, and potential environmental damage, making proactive management essential. Mechanisms of corrosion, SSC, HIC, and general thinning. Acid-sour water corrosion manifests through multiple mechanisms. Sulfide stress cracking, SSC, occurs when high-strength steels under stress become brittle and crack in the presence of wet H2S, hydrogen-induced cracking, HIC, and stress-oriented hydrogen-induced cracking, SOIC, result from hydrogen atoms diffusing into steel, forming molecular hydrogen in voids and creating internal pressure that leads to cracking. General thinning is another common effect, where metal loss occurs uniformly across surfaces exposed to acidic sour water. These mechanisms compromise equipment integrity and can propagate rapidly if not detected early. Understanding these failure modes is critical for implementing effective inspection and maintenance strategies. Industry Standards and Guidelines, NACE MR 0175, ISO 15156 Compliance. To mitigate risks associated with acid-sour water corrosion, industry standards such as NACE MR 0175 or ISO 15156 provide detailed requirements for material selection and environmental limits. These guidelines define acceptable ranges for H2S partial pressure, pH, and chloride content, ensuring that materials used in sour service environments can withstand corrosive conditions. Compliance with these standards is not optional, it is a critical component of safe and reliable operations. Failure to follow these guidelines can result in equipment failure, safety incidents, and regulatory penalties. Therefore, engineers and operators must incorporate these standards into design, material procurement, and operational practices. Prevention and management strategies, material selection, monitoring, and treatment. Effective management of acid sour water corrosion involves a multi-pronged approach. Material selection is paramount. Resistant alloys such as stainless steels or specialized corrosion-resistant materials should replace carbon steel in critical areas. Continuous monitoring of pH, H2S levels, and chloride content helps detect changes in corrosivity before damage occurs. Sour water stripping, SWS, units are commonly employed to remove H2S and ammonia from process water, reducing its aggressiveness. Additional treatments may include chemical inhibitors and scavengers to neutralize acidic components. Proper system design, including minimizing turbulence and controlling temperatures, further reduces corrosion risks. Implementing these strategies ensures equipment longevity and operational safety. Summary and key takeaways, critical insights. Acid sour water corrosion is a severe challenge in oil and gas processing, driven by the presence of H2S, low pH, and inadequate neutralization. It leads to mechanisms such as SSC, HIC, and general thinning, posing significant safety and operational risks. Compliance with NACE MR 0175 or ISO 15156 standards, careful material selection, and proactive monitoring are essential for mitigating these risks. Treatment methods like sour water stripping and chemical inhibition further enhance protection. Ultimately, understanding the corrosive nature of acid sour water and implementing robust management strategies are critical for maintaining equipment integrity and ensuring safe, efficient operations.